Today what we're going to talk about is lesson 2-4, opposites. The big idea, the opposite, negative k, of a number has properties relating to its addition, multiplication, and subtraction. For instance, negative k plus k, so the opposite of k plus k equals 0. Negative 3, as you all should know, negative 3 plus 3 gives me 0. Okay? Negative k is equal to a negative 1 times k. Should make sense. So what they're saying is a negative 3 is equal to a negative 1 times a positive 3. Once again, should make sense. And a minus k is equal to a plus a negative k. So what they're saying is 5 minus 3 is saying the same thing as 5 plus a negative 3. 5 minus 3 is 2. 5 plus a negative 3 is also 2. Now, Mr. Johnson hates it when people write it with two symbols. So we don't talk about this very much because I hate this. Why have two symbols? Okay, it just confuses people. Get rid of the two symbols, make it one symbol. That way in algebra you know what you are going to do. Real numbers, k and a negative k, are opposites. You have dealt with opposites in previous lessons. In this lesson we look at some of the basic properties of opposites. It says, suppose you walk forward 10 steps and then walk backward 10 steps. We signal these opposite directions by calling it walk forward 10 and walk backward 10 is a negative 10. The result of doing these actions one after the other is to end in the same place where you started. So 10 plus a negative 10 equals 0. You're in your same spot. When two numbers add to 0, they are called additive inverses or opposites. When two numbers add to 0, they are called additive inverses or opposites. Because they signal opposite actions, another name for additive inverse is opposite. So if two real numbers, x and y, are opposites, then their sum is 0. Reversing this, you will know that x plus y equals 0 and x and y must be opposites. Okay, this should be obvious. The numbers k and a negative k are opposites regardless of the value of k. If k equals 5, then a negative k equals a negative 5. If k equals a negative 10, then a negative k equals a negative 10, which is a positive 10. When k is negative, negative k is positive. Okay? That all should be obvious for us. Okay? Here's our opposites property that you want to put in that you're probably going to have to know for a quiz or a test. For any real number a, negative a equals a positive a. Yes, we should know that. What is the opposite of each number? Well, what's the opposite of a positive 3.5? The opposite of a positive 3.5 is a negative 3.5. What's the opposite of a negative 17/8? You're going to tell me a positive 17/8. If one's negative, the other one's positive. One's positive, the other one's negative. Real hard stuff. I know. We're talking about this in high school math. Unbelievable. Multiplication property of a negative 1 for any real number a. A times a negative 1 equals a negative 1 times a. Okay, it says the same thing. Refer to the examples at the front of the 2-4 page. And I gave you some. Opposites of a sum property for all real numbers a and b. A negative times a quantity a plus b equals a negative a plus a negative b. Okay, just distributed the negative sign. Negative a plus negative b equals a negative a minus b. See, notice they wrote it with just one symbol. That's what Mr. Johnson likes. So here, for example, a negative times 15y is a negative 15y. A negative times a positive 3 is a negative 3. Simple. Don't let it confuse you. Moving on. Quiz yourself too. Simplify. A negative times the quantity a squared plus 2b. So I got to take this negative times a squared. Well, a negative 1 times a squared is a negative a squared. And a negative times a positive 2b is a negative 2b. Can you combine these? No. Why can't you combine these? These are alphabets. These are betas. Can't combine them. Don't do it. And here's your opposite property when you have a negative sign in the middle. Obviously, this negative is going to turn this negative positive. Yes. Negative times a positive is a negative. A negative times a negative is a positive. Okay? Opposite of a difference property. Should be common knowledge. Let's look at example 1. Simplify 4x minus 3x, the quantity 3x plus 7. If you have a quantity, you need to get rid of the parentheses. How do we get rid of the parentheses? Well, we have a negative sign. So I got to take a negative times this. I got to take a negative times that to get rid of my parentheses. So I just write my 4x here. A negative times a positive 3x is a negative 3x. A negative times a positive 7 is a negative 7. Combine like terms. Where are my like terms? Well, 4x and a negative 3x. That means 4 minus 3, which is 1x. You don't have to write the 1 there. I normally do not. So I'm going to erase it. 1x. And then I bring down my negative 7 because it has nothing to join with. And that is your answer. You can't combine the 7 and a negative. You can't combine x and a negative 7. These are two different things. This has labels of x. This has no labels. Example 2, same thing. Simplify the quantity x plus 6 minus 7 times the quantity 2x minus 3. Now, if there's nothing in front here, that's just like saying 1 times anything. So if you take 1 times anything, you just get its self. The parentheses are gone. Here, this has a negative 7 in front of it. So I got to take a negative 7 times 2x. Well, a negative 7 times 2x gives me a negative, because a negative times a positive is a negative, 14, 7 times 2, x. Okay? A negative 7 times a negative 3, a negative times a negative is positive. 7 times 3 is 21. Combine like terms. I got an x and I got a negative 14x. Okay? So I got $1 and I get a bill for a negative $14. I'm left with $13 in the hole. Then I got like terms 6 and 21. They're both positive. So 6 plus 21 is 27. That is opposites. Take your time, know what you are distributing. Everything will work out just fine. Show your steps. Keep it neat. Mathematicians are neat, just like Mr. Johnson. Thank you very much. Have a good day.